Give me a little idea regarding the shape. Upside down parabola is going to be shifted up 12 units. Yeah, and it's symmetrical about the y-axis. I mean, it splits evenly on both sides, you know. So the deal is that there's a rectangle that sits inside of that. And the rectangle has corners that are on the parabola, and its base is on the x-axis. Huh. So what's our goal? Yeah, largest area is what's driving this problem, right? We end up having to find the dimensions, but largest area is what's driving this problem. So area is equal to, and I'm going to write it as length of the base times the height. And already I don't like it because, you know, you got two different variables there. You got base and height. We need to find one of them. So I'll go base is equal to and height is equal to. Oh boy. Base? Anybody? I'll give you a hint. Suppose that we make this a coordinate of x, y. Yeah. That's it? Blah, 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 blah. You said 2xy? 2x. How come? Yeah, if you go x in this direction, and if you go x in that direction, that's a total distance of 2x. Everybody agreed? Yeah, good. Base is 2x. What's the height? Y. Yeah. Good job. So we got the area is equal to 2xy. Oh, shoot. We still got two variables, don't we? Nah. Wouldn't it be great if, like, we knew what y was equal to? We do. We do? Oh, my goodness. You've got that right there. We can put that right in for y. Look at that. Way to go. Good job, Shelly. Duh. Yeah. Duh, everybody. That's all right. No, you wouldn't say it like that. I get you, Shelly. Area is equal to 2x times 12 minus 3x squared. There we have it. And so we have area is equal to 24x minus 6x cubed. Okay, that's another cubic, just like I drew on the other spot, right? We want to maximize that. If we're going to take the derivative, what's the derivative?
24.
Cool. Oh, squared, yeah. Got to solve that guy. So, you know, if you want to, you can use the quadratic formula right here. Should we do that? Or do you want to use algebra? Do our calculator. We'll turn it on. Clear. And I can go to program and execute my quads. And I've got my A value is negative 18. My B value is 0. And my C value is 24. And notice I get 1.15. So x is equal to positive or negative 1.15. So you can see that the maximum occurs at a value of x is 1.15. So that's not my answer. The goal is to find the dimensions. So I want to know what the base is equal to. And I want to know what the height is equal to. What would the base be? 2.3. How'd you get that, Colin? Yeah, you know x is 1.15, so you plug it right in for x, you get 2.3. Good. And then how would we determine the height? Yeah, plug the x in for the original equation for y, and so I've got 12 minus 3 times 1.15 squared. 8.03. Not too bad, huh? I like it. We're going to skip the next one. We're going to move here. Find the equation for a line tangent to that curve that has the largest slope. Find an equation for a line tangent to that curve that has the largest slope. What does the curve look like? Upside down cubic. So, it's going to be worthwhile for you to think about it a little bit. I want you to see if you can say anything intelligent about the problem, anything intelligent about it before we actually start tearing into it, because some of this should end up being fairly intuitive to some people, and for those it's not, we'll help you out, but go ahead, take 1 minute, see if you can say anything intelligent about it. Go ahead, go. Okay, who's got something to tell me about the largest slope? Yeah, Esther. Yeah, exactly. So, so when we look at line tangent, we're looking at a derivative, and then when we say largest slope, we're looking at derivative as well. We're going to look at a second derivative here. Anybody else tell me something interesting about the problem? Yeah, say it. Inflection point. So you guys, so watch this happen here, okay? How would you describe the derivative here? Negative. How would you describe the derivative here? How would you describe the derivative here? So if we're looking for the largest, I would hope that everybody would be able to look at this curve and say when it has its largest slope, meaning it's on its way up at the greatest. You tell me when I get to that spot. Yeah, and if you look at that, hopefully you remember, because we just tested on it, isn't that appear to be the point of inflection where it changes concavity? Yeah, and so just trying to wrap your brain around what the problem is asking to begin with can really help, but that is an important piece there. So it says find the equation for line tangent. Well, I know I need two things. Number one, I need slope, right? And number two, I need a point. Everybody agreed? So I want an equation for slope, and then I want to find inflection as well, okay? So let's take the first derivative, okay? F prime. What is it? Good. So does F prime, does that tell me slope, or does that tell me inflection? Slope tells me slope, right? So this is where we're going to get our slope. Second derivative, f double prime of x is equal to negative 12 minus 4x. Sorry, 6x. Does this tell me slope, or does this tell me inflection? It tells me inflection. So that's important. So we'll solve for where the inflection happens. We know the inflection is where it's equal to 0. So 0 is equal to negative 12 minus 6x. Or 12 is equal to negative 6x. So x is negative 2. So I found my x value. My x coordinate is negative 2. Whoops, sorry. Negative 2. How would I find the y value? Plug it into which one? I've got three equations up here. I got f, I've got f prime, I got f double prime. I plug it into f in order to find the y value, right? So I'll take out my handy dandy calculator. Actually, no, we'll use the calculator. We'll go 2 parentheses negative 2 minus 6 times, well, we got negative 36. We'll see if that guy's right. Not that Colin has ever made a mistake before. Oh, wow. Very humble man. I got negative 20. Anybody else? Sounds about right. Okay, how do I find slope? I go to my slope equation, I plug in -2 there. And I go 2 minus 12 times -2, and then minus 3 times -2 squared. And I get 14. Is that enough information to write the equation for the line? It sure is. I have y plus 20 is equal to 14 times x plus 2. Or y plus 20 is equal to 14x plus 28. Y is equal to 14x plus 8. Not too bad? We've already done an example like 7, correct? Problem 9 is the gutter problem, one of my favorites of all time. But it takes way too much time, and we're gonna have to cut that one off. But we will do number 8, and that's what we will end with for optimization. This is your last of the word problems. So. Find the equation for the line through the point 4, 2 that cuts off a triangle from the first quadrant with the smallest area. Okay. Need to find an equation for a line that passes through 4, 2 that cuts off a triangle with the smallest area. We do have economics applications. We don't have time to get to those, but this is kind of the last one we were with. And the nice thing is you only need 2 things in order to do this. You need slope and you need a point. Which one do I currently have? So all we have to do, it's a very small task. We just have to find the slope of the line. No big deal, right? We can do it. We can totally do it. Okay, so all of a sudden it appears kind of challenging because when we think about this, we know that the area of a triangle is what? Yeah, we got 1/2 times the base times the height. Huh. We don't know what the base is, do we? And we don't really know what the height is, do we? So I'm going to make this a coordinate, and this a coordinate. Does everybody agree that this is the x-intercept? I'm going to say that it has an x-intercept of b, whatever the base would be, and then 0 for the y value. You okay with that? And we're going to say that this has is a y-intercept, and we're going to call it, anybody know? 0h. Good job. Well, now it's not too bad. We're going to write an expression for b, and then we'll write an expression for h. Okay. So we'll write an expression for b. We'll write an expression for h. And I'm going to use the only thing that I know, which is an equation for a line. And we know that an equation for the line is of the form y minus y1 is equal to m times x minus x1. What is the unknown thing that we're trying to find in this equation? Trying to find m, right? What is the thing that we know? Yeah, we know the point. We know x sub 1 and y sub 1, right? So let's put that in there. We now have the form y minus 2 is equal to m times x minus 4. Notice that for b, I have an x value and I have a y value, don't I? Let's plug those in. What do you plug in for y? 0. And you have 0 minus 2 is equal to m times what goes in for x? B. So if I go ahead and simplify this, I get negative 2 is equal to m times b minus 4. I want to solve for what b is. In order to solve for b, I'll divide both sides by m. Negative 2 over m is equal to b minus 4. And then I will add the 4 to the other side. 4 minus 2 over m is equal to b. Everybody okay with my solution there? So that means as I write area, I have area is equal to 1/2 times 4 minus 2 over m. Now I'm going to do the same thing for h. Notice my equation for my line. What am I going to plug in for x and what am I going to plug in for y? 0 for x and h for y. So I get h minus 2 is equal to m times 0 minus 4. Or h minus 2 is equal to negative 4m. Or h is equal to 2 minus 4m. So notice the h here, and we get 2 minus 4m. Look at the beauty of the problem. I mean, isn't it nice? We're trying to figure out m, aren't we? And look at our equation here. The variable we ended up with was m, wasn't it? The first time I looked at this problem was in calculus class about 8 years ago. And we didn't do it. We simply presented it. And they said, there's no way. No, actually, we were going over it. And they said, well, you'll never put anything like that on the test. I said, well, if I did, I said, I'm sure you could figure it out. And they said, no way, we're not capable of it. I said, okay, all right, it's on the test, I promise. They'll be like, what? We're all going to fail. And actually, people, I mean, by and large, everybody got it right. And so you find out you're capable of a lot more than what you think right away. But it works out pretty nicely at this point. I'm going to distribute the 1/2 through. I'm not going to distribute. Now, I want you, our kind of our number sense starts to leave us at this point. Suppose I had 1/2, don't write this down, 1/2 times 6 times 8. Would everybody agree you don't take 1/2 times 6 and 1/2 times 8? Yeah. Everybody agree you don't multiply both of those? So I'm not going to take 1/2 times both of these things. I'm just going to do the easier one. And so so here we go. I've got area is equal to 4 minus 2 over m. And then I'm going to take the 1/2 times this guy to get 1 minus 2m. Now, I don't want to take the derivative like that. That looks really tough. I mean, I would have to use the, product rule and let's just multiply it all out, huh? So area is equal to, and this works out pretty nice. I mean, 4 times 1 is 4, like that. 4 times negative 2m is negative 8m. Negative 2 over m times 1 is negative 2 over m. And then when I take negative 2 over m times negative 2m, what's going to happen to the m's? Yeah, isn't that nice? I mean, it's really nice. So you just get what? You get just plus 4? Plus 4? And doesn't that just connect with the other 4? So you have area is equal to 8 minus 8m minus 2m to the negative 1. It is 2m to the negative 1, right? What do I want to do with it now that I've come up with a function? Take the derivative and set it equal to? Because that's where a maximum occurs. What's the derivative of 8? 0. What's the derivative of negative 8m? Negative 8. And what's the derivative of negative 2m to the negative 1? 2 over m squared. So 0 equals negative 8 plus 2 over m squared. So I add the 8 over 8 is equal to 2 over m squared. How do you want to solve that? Sure, you could do that. We could put it over one end. Cross multiply as well. 2 times 1 is 2. Equals 8m squared. Divide by 8. 1/4 is m squared. What's the square root of a fourth? A half, right? M is equal to plus or minus 1/2. Look at the line, folks. Is it a positive 1/2 or a negative 1/2? It's a negative 1/2. You can tell it's the negative, so the slope is negative 1/2. As we write our equation for our line, y minus 2 is equal to negative 1/2 times x minus 4. Or y minus 2 is equal to negative 1/2 x plus 2. Or y is equal to negative 1/2 x plus 4. This cake upside down. I'm not going to show you the last problem, but I do just want a quick, just at least just give it a general glance. Has anybody ever had somebody come and put gutters up at their house? You never watched it? Everybody knows what gutters do, right? And so what's really cool now is when gutters go up at your house, they have these things called seamless gutters. So what happens, they have this large kind of roll of aluminum material, okay? And what they do is they unravel a stretch of it, okay? They unravel a stretch of it, say, like 25 feet long, whatever. And it, comes out as a nice flat piece of aluminum like so. Well, you don't attach a flat piece, do you? You got to bend the sides up, right? So they put in what they call a metal brake. That's something that actually bends it. So they, maybe bend it here, and they bend it here. And what happens is if you look at the end of it, then you get a gutter that's like this shape, right? So the question is, what angle should you bend it at in order to maximize the volume of water it can carry? I mean, and if people are like, first time I did this, people were like, well, that's just stupid. Like, nobody's going to go out there and do the calculus before they attach the gutters. And I'm like, you're right. There's one person that did it, so then the company could know it for everybody in that situation. See what I'm saying? But that's a reasonable thing to think about, isn't it? I mean, you don't just want to bend it at 45, just be like, well, I don't know, it's just what I was thinking about. I mean, you kind of want to know, what's the general amount that you should bend it. And if you don't like that one, then I mentioned this one to you before. This is the problem that my calculus teacher brought to us, but the question was, what angle should you put the branch of an artery at in a as you're doing a bypass in order to minimize the friction of the blood flow? And so that's another thing I used to take people through during this time. I'll post a link for a video just in case anybody's super curious and wants to check it on out. Take out your homework. Let's go. Let's tell you which problems do, which problems not do. And the next thing that we're going to do, I would say, is definitely a step below what we're doing now. The last 2 lessons that we have before the semester's over, I would say the level of how complicated things are reduces. So without a doubt, word problems tend to give people a little bit of run for their money. But fortunately, you're extremely intelligent. So there you go.